Acceleration graphs. In this module, you will learn how to interpret a velocity time graph. You will learn that velocity time graphs provide useful information about the magnitude and direction of acceleration. The slope or gradient of a velocity time graph describes the magnitude and direction of the acceleration of a moving object. The area bounded by the curve and the time axis of the graph gives the displacement the object undergoes during that particular period of time. Let's check out the meaning of the slope of a velocity time graph. Shown here are graphs of different types of motions. You may notice that some are parallel to the time axis, while some slope upwards with a positive gradient, and others slope downwards with a negative gradient. You will understand each one of them one by one. Let's first understand the meaning of gradient or slope of a velocity time graph. The gradient of the velocity time graph is defined as the ratio of the change in velocity to the change in time, which is the acceleration of the moving body. Thus, the gradient of the velocity time graph indicates the acceleration of the moving body. Thus, you would notice that the area enclosed by the velocity time curve and the time axis for a particular time period gives the displacement the object makes in that time period. Consider a car moving with uniform velocity. Since the velocity is constant, in accordance with Newton's law of motion, it depicts zero acceleration. You can see that the velocity time graph of the car is a horizontal straight line parallel to time axis. The gradient of this curve is zero, indicating that acceleration is zero. We thus conclude that the velocity time graph of an object with constant velocity or zero acceleration is a horizontal straight line parallel to the time axis. Since the area enclosed by the velocity time curve and the time axis gives the displacement of the moving object, the displacement of the car during the time period when it is moving with uniform velocity can be calculated as shown. Let us now study the motion of a car moving with uniformly increasing velocity. As v2 is greater than v1, for t2 is greater than t1, its acceleration is positive. We can observe that for uniformly increasing velocity or positive acceleration, the graph is a straight line with a positive upward slope or gradient. We thus conclude that if a velocity time graph is linear with a positive gradient, it indicates that the object is moving with uniformly increasing velocity or uniform positive acceleration. For a linear velocity time graph, when we calculate the car's acceleration for different values of time, keeping the time interval constant, we find that as the change in the velocity of the car is equal in equal time intervals, the acceleration remains the same. This is supported by the fact that the gradient of the graph during those time intervals does not change. Since the area enclosed by the velocity time curve and the time axis gives the displacement of the moving body, the displacement of the car during the time period when it is moving with uniform positive acceleration can be calculated as shown. Let us compare the graphs of two cars A and car B. Both of them are moving with a uniform acceleration. However, the rate of change of velocity is different. From the graphs of the two cars, you can observe that the gradient for car B is steeper as compared to car A's motion. This indicates that the velocity of car B is increasing more steadily than car A's, or car B is accelerating more than car A. We thus conclude that a large gradient indicates a high acceleration compared to a small gradient. Let us now study the motion of the car moving with uniformly decreasing velocity. As v2 is smaller than v1, for t2 is greater than t1, this means that the velocity of the body is decreasing every moment, or in other words, has a uniform negative acceleration or retardation. As you can observe, the graph for uniformly decreasing velocity or negative acceleration is a straight line with a negative downward slope or gradient. Thus, from this you can conclude that if the velocity time graph is linear with a negative gradient, it indicates that the object is gradually slowing down or moving with a uniform retardation. Finally, let us study the motion of a car moving with variable velocity, that is, non-uniform acceleration. As you can observe that unlike for uniform acceleration, retardation, this graph is a curve with direction of the gradient changing every moment depending on whether the velocity increases, decreases, or remains constant. We thus conclude that if the velocity time graph is a curved line with gradient changing in accordance with the changing velocity, it indicates that the object is moving with a non-uniform acceleration. Instantaneous acceleration is the acceleration of the body at any given instant of time. This quantifies the change in velocity at different instants for the same interval of time. It compares the acceleration of the body at two adjacent instants of time, indicating the change in magnitude and direction, and thus the slope at those points. Let us now calculate the instantaneous acceleration of the car at any instant of time during the journey when it has a non-uniform acceleration. This is done by finding the gradient of the tangent at that point on the curve. Let us now sum up what we have learned by studying an example of a car whose acceleration changes during different intervals of time during its journey. We'll calculate the acceleration of the car during these different intervals of time. In the example of a car that moves with changing acceleration during different intervals of time, let us now calculate the total displacement of the car during its journey. This displacement is calculated by finding the total area under the velocity time curve that describes the motion of the car. In this module, we have learned the slope of velocity time graphs give acceleration of the moving object. A velocity time graph that is a horizontal straight line parallel to time axis indicates that the object is moving with a uniform velocity and has zero acceleration. A curved line velocity time graph indicates that the object is moving with a non-uniform acceleration. The gradient of the velocity time graph gives the acceleration of the moving object. A constant gradient indicates a uniform acceleration. Increasing gradient indicates an increasing acceleration. Decreasing gradient indicates decreasing acceleration, and zero gradient indicates that the object has zero acceleration. A positive gradient indicates that the object has positive acceleration, while a negative gradient indicates that the object has retardation. The area enclosed by the velocity time graph and the time axis gives the displacement of the object in that time period. The instantaneous acceleration of the object at any instant of time is calculated by finding the gradient of the tangent to the curve at that point.